My name is Joseph Roy. I used to be a STIC student. I literally was sitting in your seat 1 year ago today. And I can't believe in that 1 year where I've gotten to right now. It's mind-boggling. The amount of responsibility that I have, the company that I work for, the equipment that I'm working with, it's all, beyond my wildest dreams. So let me get started and I'll show you where I ended up after graduation. So I work for IPG Photonics. It's based out of Oxford, Massachusetts. And let me tell you a little bit about myself before we really delve into it. Like I said, I graduated from here in May. I don't know if anybody told you, but I was the guy who did that solar car thing. It was a hot mess. It was good fun though. Yeah, it took solar power to charge a bank of batteries in a golf cart, and we also R&D'd a compressed air engine. We wanted to make it a truly clean vehicle, and STIC was amazing because they funded the whole thing. Basically gave me my tuition back. And I got to meet some really cool people. I met Senator Elizabeth Warren. No matter what your political views are, it's still cool to meet an active sitting senator. And she was really interested in the project. So IPG Photonics is a manufacturer of fiber lasers and fiber amplifiers. It's headquartered in Oxford, Mass, like I said, and it operates internationally. IPG Photonics developed and commercialized optical fiber lasers, which are used in a variety of applications, including materials processing, medical applications, and telecom. IPG has manufacturing facilities in the United States, Germany, Russia, and Italy. I really feel like I got in on the ground floor of something kind of amazing. Not the ground floor, maybe the third or fourth floor. IPG is experiencing a meteoric rise in technology, in capital that it's generating, and overall name recognition. But I don't know how much Dr. Massa praises IPG. I know he really loves it. They do a lot of crazy cool stuff, and as you can probably tell from this graph over here, our sales and our revenue has been going up every year since I started and way before I started. They went public in 2006, so now they're a publicly traded company, which was a huge influx of capital for us to further develop our systems, which we were able to invest in a vertical integration. So basically, we don't have a lot of outside vendors. We make everything in-house. And to make a fiber laser system and to do it all in-house, you have to be big and you have to be well capitalized. So we do everything from the YLRs, which is basically a marking laser, low power, maybe 50 watts, all the way up to these higher rackable units, which you can go 1,000, 2,000, or 5,000. Those are 5,000 watts. Those are actually, doesn't even come close to what we're capable of doing. As I was just telling Pete, your professor, I recently just worked on a 50 kilowatt laser, which can blast a hole right through this concrete wall in no time. Before I got there, they did a 100 kilowatt laser. That was for the military to shoot drones out of the sky with. Obviously, I don't know too much about that one. So I work for a specific part of IPG. It's a huge company, but I work in what's called Systems Group. In Systems Group, basically, we don't make the lasers. We make the lasers do work. So we're trying not only to build laser systems for the market, but we're also trying to give customers, end products that are usable. These right here are called multi-axis machines. Basically, they have an X, Y, Z stage. They also have a couple of rotaries on it. So stuff like the machines like this are basically made for doing high precision medical parts, cutting stents, doing probes for laparoscopic surgery, stuff like that. We do a lot of work in tandem with the medical industry. So again, Systems Group, it's all in the name. We do not only with lasers, but we deal a lot with electromechanical. The term is describe machinery and processes which are made up of both electrical and mechanical components. These systems can be as simple as a push-button motor starting a circuit, or as complex as a complete industrial process. These are all IPG lasers. Has anybody drove a car here today? Okay, so basically your car is laser welded. There's not humans on the line anymore that do that kind of work. So it goes down an assembly line. These are all pre-programmed. These lasers are all fiber lasers, and they go through their sequencing and boom, 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 boom. That's why cars are so affordable today.
Are the robots IPGs also?
No, the robots are a separate entity. We deal with the laser system, but we work in tandem with industry. We don't, I think these are phonic robots. We work primarily with KUKA robots. They're German. We have a lot of connections with Germany. So, in systems group, like I said, yeah, it's for building systems, but we're also the primary R&D facility for the whole international company. Now, they got multiple research and development areas throughout the world, but Oxford is their world headquarters, and I work in that department, which is pretty cool. We're developing a 3D, single-mode 3D printer laser system right now. Now, of course, 3D printers have already been invented. This is, nothing earth-shattering. But the way we're delivering it through a single-mode high-power fiber is we're going to be able to micro 3D print like the tiniest of machine parts. This is to really change the industry in getting smaller, faster, more reliable stuff. Some of the projects that we've been working on. I can't tell you everything we've been working on, obviously, but I can gloss over and give you the general gist of what we're talking about. These are the KUKA robots that I was telling you about. If you come into systems group, you'll have to learn how to program these things, which, let me tell you, you need a master's in mechanical engineering to even begin to start how to do this. But it's by, delving into the material that you need to learn. You have to be around it, 10 hours a day, 6 days a week to really start to even come close to understanding this. You guys are getting out with an associate's degree. I thought that was going to hold me back. Actually, it's not. Let me tell you, you can do a lot more things than a lot of people with master's degree do, the bachelor's degree. The things that I work on right now are primarily made for physicists. So physicists like to stay in their office, they like to work on their computer, they like to do calculations, they like to do all that stuff. That's the time that they need allotted to do their work. Well, when these theories come out of these offices, somebody's got to build it. Somebody's got to understand the process that they want. So that's where you come in. You guys are the boots on the ground. And let me tell you, it's fascinating. This right here is a high-powered scanner. Now, you guys have all seen scanners. They have a couple of galvos that can direct laser light, and that laser light will suddenly do work. What we're developing right now is a high-powered scanner. This scanner can deliver a 10,000 watt laser, which would blow up most systems. So what we do is we have to develop cooling systems that will be able to cool the optics so that all the glass doesn't melt while we're driving 10,000 watts through this thing. So it's actually pretty interesting stuff. You have to, being a plumber comes in real handy. So also as a technician, you have to test and debug. You have to, trust me, when these things go together the first time, they never work. They never ever work. You have to figure out what's wrong, because you are, just in the name implies, you are researching and you are developing. So be prepared for failure. All right, go ahead. So right now we're testing the galvos. It seems to be, the video doesn't seem to be working that well for some reason. Anyways, so these galvometers, the lasers going through, we're putting a test laser through, and we're moving them back and forth to see if they can be aligned on a wall on about a foot away. Yeah, this is not working. Sorry about that. See if this one works. All right, so basically, after we start calibrating it, we do test scans on a piece of metal. And this test scan will let us know if our optics are aligned, if the galvanometers are working properly, and we go through all sorts of different computer simulations. I'm just going to skip over this because it doesn't seem to be working too well. And this doesn't look like it's probably going to work too well either.
Yeah, go ahead.
So we're just going to skip past that. Okay. So anyways, basically that last video was showing us blowing apart a steel plate. And it worked really well. We only had 3,000 watts going through it, but it was able to do a grid pattern at lightning speed, and that's going to be used for 3D printing, for auto manufacturing, for all sorts of other industries, the shipping industry. After that test, has Dr. Massa told you about burn-in testing and stuff like that? When you finally get the laser and it's ready to be sold to a customer, you have to make sure that you do quality control on it. You have to make sure that it's working properly. You have to make sure all the systems are repeatable. You got to make sure all the push buttons work. So what we did with that high-powered scanner is we ran it through a FLIR, which is a forward-looking infrared. And we wanted to make sure that none of the parts were overheating. And lo and behold, you can probably tell this is an older picture of a test we did. This whole inner part of the high-powered scanner was getting red hot, and we couldn't figure out why. Well, it turns out after a lot of trial and error, basically when the laser was coming out of the fiber, it diverges, and it was clipping the side mounting plates that was holding the optics. So the optic wasn't taking the whole beam. Some of the laser was actually hitting the brackets that hold the optics in place, which would heat up those brackets and explode the optics. So we basically changed the focus length, we ran more cool water through the system, and we solved the problem. And that's the image on the top.
But you put the mounting bracket for the lens in a water.
Yeah, basically these mounting brackets, they have channels that we run deionized water through. And we do it at a very fast pace to draw that heat away as fast as possible. Other things that we've been working on. Space travel. Has anybody heard of Blue Origin or SpaceX or anything like that? Okay, anyways, these folks came to us, they're trying to build brand new kinds of rocket engines. Blue Origin came to us, they're building something called the BE4 engine, which is a small, compact, high-power rocket engine that they're going to do for space tourism. Basically shoot people into space, pay $10,000, you can be an astronaut for a day kind of a thing. So they have special alloys to make this engine out of, because the thrust variant that these things are going to take is going to be, it's under high pressure, high temperature. So they had to be able to weld these different levels of this copper material, this copper alloy that's highly secret, only to Blue Origin. We didn't exactly know what the alloy was. And they had to weld these parts together. Well, what's the best way to do it? The best way to do it is with a high-powered laser system. So we basically had to design a turntable. You can see over here in the corner, this is us unboxing a lot of our stuff that we were going to use for the system. There's a turntable in the back, so this rocket engine would go on this turntable. This robot, as the turntable was moving, this robot would go with its scanner head, and it would do all the high precision welds as the engine turned. It also had a track that it was mounted on. It took months to build this thing, and it took months to debug it. And it took another month for us to finally get it to work. So, but all in all, 6 months to develop something like this, you know, is really fast. And we're talking like 15-hour days for 6 days a week for 6 months. You know, I mean, you want to talk about learning and learning fast. Yes, it's one thing to come to class and to hear Dr. Massa give a talk, and it's a total another thing to be immersed in it and have to solve problems immediately because you're on a deadline. They're two different animals, so you should be prepared for that. This is the final look of the robot once we got it done. it had two different aspects to it. It had what's called a welding head. That's what actually would weld the pieces together. Notice the plumbing. It's really easy to figure out what's hot and what's cold. So obviously the blue is the cold water inlet, the red is the warm water return, and it goes back to a chiller. Remember, cooling is everything in lasers. This is a cladding head. So after we would weld this rocket engine, they wanted to put a special titanium coating on it. Well, you need a different system for that. So this is a titanium powder-fed cladding head. Basically what that would do, it shoots tiny titanium balls at supersonic speed. And it doesn't exactly melt the titanium. What it does is it softens the surface for the titanium to interact with. So basically you're shooting it into this material. You're not melting it into it, you're lodging it into it at high speeds and high temperatures. And it makes something like this, which I will pass around in 1 second after the next video. So, to go on with cladding, this is another one of our machines. This is called the supersonic cladder. What is the purpose of a cladder? What can it do for industry? It can do amazing things. Basically, we got a call from the shipping industry one day, and they were like, you know, we want to coat our propeller shafts because it's so expensive to retrofit one of these things or pull them out and put a highly expensive alloy into these machines for these prop shafts. So what they wanted to do is use a less expensive material and coat it with a titanium material, which is it doesn't degrade in seawater, it can handle high temperatures, and it's something that when the shaft wears out, all you would have to do is pull the shaft out, send it through the cladder again, remill it, and reuse it. So you're going, instead of pulling a prop shaft out and replacing it for $150,000, you're pulling it out and you're recladding it for $7,000. So it's a huge savings. So we developed this system. I'm really hoping that this video works. On the left, we're actually learning how to clad surface material. And this is being shot, it's going slowly, but you'll get the point. We're shooting this titanium at supersonic speeds onto this metal plate. And the laser is going at it at the same time. I believe this is a 10 kilowatt laser. So actually, this is good. You can see it in slow motion. It's getting shot and the laser is happening simultaneously, and they are not welding, not sintering, you're impacting.
Like impregnating.
You're impregnating the steel with another steel. You're actually making it into, you're getting all the expense of one metal, but you're giving it all the qualities of another metal. So it's really cool stuff. And on the other side, this is how we do the shafts that I was just talking about. Also, it has other uses like coating the inside of a gun barrel. The Abrams tanks, gun barrels wear out after a while, but if you did something like this and would coat it with titanium, again, you're talking about huge cost savings. Skills you will need. This is kind of the nitty-gritty stuff. I just wanted to give you a brief overview of what we did there. But when you go out into industry, you think you're going to have your hands on, all the biggest and best lasers out there. More likely than not, you're going to be dealing with electromechanical. And one of the first things and most important things that I needed to learn when I got out was learning how to solder properly. Because all this stuff is based on electrical components, electronics, computers. You have to be able to know how to troubleshoot this stuff, and quickly. So, but a lot of the kids today have skills like this. If you don't have skills like this, all I could suggest is
come see us in electrical.
Come see him in electrical. I actually think STIC should teach a practical electrical soldering class and stuff like that. Maybe they do, I'm not sure.
We did it in project management.
It gets done Gets done in
Maybe
several of the
something like
electrical
that,
courses, but
Should be included in some others too, though.
you know what? I'll suggest that to Ed.
Yeah, I mean, honestly, because that's really the nitty gritty, is learning, opening up a set of plans, electrical plans. Can you follow the wires properly? It's going to the PLC, it's going to the drives. Can you read it? Can you follow the instructions? Can you solder it properly? Let me tell you, one thing that I found, electrical engineers hate coming down and seeing a crappy soldering job on their Mona Lisa schematic that they made the night before,
It's
so.
always before.
Being able to work with your hands, you know, I know we live in the age of computers, I know we all like to do SolidWorks or CAD and, you know, but as technicians, you guys, like I said, are the boots on the ground. You have to be able to turn a wrench. You have to be able to, you know, just get your hands dirty every so often. The reason why I chose these photos, because these were the first photos I took of IPG, and this was like the first project I was thrown into. And let me tell you, I was wet behind the ears. I knew nothing about what I was getting into. And this was my first project. One of my instructors came up to me and was like, okay, you know, for some strange reason, this high power scanner isn't firing properly, it's overheating. We need you to replumb the whole thing. And I was like, what? I don't even know what you're talking about, or, but I had to sit there for 2 days and figure it out, you know, and go through all the plans and go through all the schematics and figure exactly what that was that needed to be fixed. This was the other side of it. This was the gas distribution system. Again, plumbing, something that I didn't prepare myself for when I got out of lasers. You know, can you use a swage lock? Can you learn how to, you know, insert gauges properly? I mean, it sounds so simple, and you take those things for granted, but when you're building one of these multi-million-dollar systems, you better learn quick how to do it. So, the reason why I'm here. I know you guys probably all have senior projects right now, right? I'm sure you do. Some people are working in New Fern, some people are working, I don't know, where else are there senior projects going on?
We just set up something with Arcor down in Windsor.
Okay, Arcor, yep. Not a lot of seniors in this class, huh? Is there any seniors? One senior, okay. Yeah. Senior citizens also, yep. We don't want to be ageist here. Yeah, if you guys are looking for a way to get your foot in the door someplace, you know, Systems Groups is looking for some people, and IPG in general is looking for people. This is why I'm here. I'm here to hunt for talent. I figured STIC was a good place to start, because it's where I got my start, and you guys have great instructors, and you know, the quality of student here is good.
You take a mechanical people too, right?
Yeah, we take, basically, this is not just for laser students. If you have mechanical engineering experience, if you have electrical engineering experience, you will be considered. Mostly what you need is drive. You have to be able to come to an interview, just say, yes, I don't have all the answers, but I will figure it out with you. As long as you'll instruct me, we'll work together on it. A can-do attitude goes a long way. Being on time goes a long way. I know this is the basics. But, yeah. You know, as Dr. Massey, you'd like to say, the soft skills. So if anybody who's interested, please take my email down. I kept my STIC student email. Send me your resumes. We will be looking for people immediately. So if you can send it to me by Friday, I will try to set you up with some sort of interview for the following week. Okay, and we are looking for people to get on the floor fast. Again, I hate to say this again, but we are a very fast-growing company, and we need people. We need raw talent. So, and we're willing to work with you if you have the drive to do it.
Is IPG doing anything with vacuum laser systems?
If they are, it's probably not in my department. So,
Because I know they used to work on
Oh, yeah.
They do have a laser I'm going to take this in your project this semester.
Spring.
Let's go.
I live in a very small bubble of systems group. Like I said, if I tried to keep track of everything IPG was doing, that would be my job. So, I have a short video, guys.
Sorry, I have to go beyond
No, no,
time for
it's
another
fine.
job, but thank you very much.
You're welcome, thanks for coming. I'm gonna show this short video. I gotta toe the corporate line just like everybody else. You know, they want me to show this to show you how great they are. So, I'll do that. I might have to switch over to my laptop because this obviously is not working with this computer.
Greatest productivity and unique reliability, compactness and versatility,
Oh, thank you.
working on a wide range of materials and easy to use and integrate, drastic reduction in energy consumption and reduced running and maintenance costs. The fiber laser is all this. There's no question anymore about what laser is most in demand in the market. It was clear long ago to many leaders in various industries, and they have made their choice. Time puts everything in its proper place, and quite fast. Much faster than anyone could imagine several years ago. A new era has begun, the era of industrial fiber lasers. The advantages of fiber lasers and the resulting new technological capabilities over the last 3 years have made fiber lasers the major driver for the growth of the laser industry all over the world. The growth of the laser market in the world primarily depends on the expansion of the material processing sector, the growth of which, to a large extent, is based on increased sales of fiber lasers. And IPG market share is 70% of the overall production of fiber lasers in the world. IPG is the absolute leader in the production of fiber lasers. This is not just because the company sells more fiber lasers than all other manufacturers combined. IPG is the founder and technological trendsetter in this field. Its leadership is based on unique research and production experience, the huge amount of know-how and patents it possesses. All this research and experience allow the company to be fully independent and ahead of its competitors in technology. A breakthrough made by the corporation in the early 90s contributed to the development of a fundamentally new technology platform with tremendous capability, unique quality of radiation and high efficiency. The availability of this platform allowed IPG Photonics to set up mass production of a wide range of industrial fiber lasers with unique features and application properties within a short period of time. The modular configuration of the laser enables flexible variation in capacity and almost unlimited upgrading to meet the customer's requirements. The lasers are provided in the most compact form factors available on the market and offer low power consumption, ease of operation, exceptionally high reliability and low price per watt. Together these advantages give customers an unprecedented level of value, which is a huge improvement over solid state and gas kilowatt lasers.
Oh, boy. All right. Let's see where we're at.
What happened?
Way back error.
I'm gonna see if I can get you to the end, where we made a really amazing laser gun, believe it or not.
It's just paused.
Capacity, superior laser beam properties and the unit's mobility contributed to the production of high-quality joints during welding of extensive surfaces of thick metal sheets. What's more, the welding sport is not overheated, and as a result, the metal
This is
sheet
also
is
for the
not deformed.
shipping industry, right? There were welding steel plates for
The compactness of IPG fiber lasers and their versatility make it possible to integrate them into any system in various fields of medicine, from cosmetic medicine to surgery. By building more
There it is.
sophisticated and versatile
We
fiber
actually built
lasers,
the laser gun.
IPG Photonics provides its customers with an instrument capable of making their operations more efficient and environmentally safe. IPG equipment alters the existing technological stereotypes and opens new possibilities, spurring the appearance of new applications of laser equipment in the most diverse areas of human activity. We're accelerating technological progress and changing the world for the
Was
better.
that underwater?
Yeah,
IPG Photonics, the power to transform.
It's pretty awesome.
oh, you can hit the lights. Sorry about all the video problems, guys. I always had problems when I was a student with this stuff too.
It
so
happens.
I should have learned my lesson. Anyways, thanks for listening. If anybody wants to talk to me after class about possibilities for employment, I want to just make it very clear, this is not a job offer. These are internships. You are here to get experience so that when you walk into any other job, or you are offered a job at IPG Photonics, let me tell you, they have a lot of positions open. You'll be ready to go. You know, you'll at least have something to say like, yes, I have experience. That's the whole point of an internship. And let me tell you, when I graduated, it was amazing not to have to look for a job after graduation. I basically went from this to this. I went from intern to employee with, you know, no effort whatsoever. So, thanks for listening.